Hello, in today's video, we'll be using static stress analysis on Fusion 360. I hope you enjoy the video. In today's video, we'll be going over Fusion 360's simulation feature. This feature allows you to simulate and test your design. This is especially useful when following the engineering design process by prototyping your parts and mechanisms. We will be using the static stress analysis on a bridge. To start our simulation, we will begin by changing our workspace from design to simulation. Over here, you'll see a multitude of simulations that can be performed onto your design. Static stress calculates how much pressure or weight an object can withstand. Model frequency can determine how objects perform under constant frequencies, or in other words, oscillating motions. Electronic cooling is a tool that allows you to visualize the temperature and air movement within electronic assemblies. Thermal determines the temperature an object can withstand. Thermal stress calculates how much force an object can withstand under different temperatures. Structural buckling is the measurement of displacement for an object that does not snap, but instead bend. Nonlinear static stress determines the effects on an object when more load is applied over a period of time. Event simulation determines the effects on an object over time as the force applied changes. Shape optimization determines the most effective geometric shape for an attachment or part to make it lightweight and cost-effective. For the purpose of testing our bridge, we will be using static stress analysis. To start our simulation, we'll be adding a mesh pattern onto our object. We will go into the mesh settings and decrease the size of the mesh for more accurate results. Mesh is basically triangular points the CAD software uses to add values such as loads or constraints. Our second step will be to add constraints onto parts of our object that will not move. These are typically the areas that are bolted or cemented into a surface. I'll be selecting all the parts on the bottom of our bridge. Now our next step will be applying a load. This is the amount of weight that our object will be trying to withstand. I'll change the unit to pounds and I'll be applying 20,000 pounds as a typical car weighs 4,000 pounds, and we are just testing to see if 5 cars can drive on this bridge at the same time. Keep in mind that the bridge is scaled to be around the same size as an actual bridge, 500 meters long. This will provide us with more realistic values. Right now, you can see a very exaggerated curve in our bridge. As we select actual displacement, our bridge will show us the actual displacement when force is applied. The exaggerated displacement shows you what your design would look like if there was a huge displacement from a great amount of force. When checking the actual displacement of our bridge, we can see that the maximum displacement when the force is applied is 15 millimeters. And the minimum displacement is 0 millimeters. If we select the stress option when viewing our bridge, we can see the parts with the most stress buildup. For displacement, we will see the parts of our bridge that is most impacted when force is applied. We can view the weakest and sturdiest parts on our bridge by sliding on this bar. This indicates the areas of the model that are most likely to fail under load. Now I'll be using the animate feature to see the displacement in real time. This feature allows you to visualize the parts of your design that may need more support. In our case, the displacement is only 7 mm. It is not enough to cause any major damage or collapsing of our bridge. Our design earned a safety factor of 15. This means that this bridge will most likely not collapse or break under the given load. If you change your mind and want to decrease or increase the load, you can edit the load by right-clicking on it and selecting Edit Structural Load. This feature allows you to change the direction the force is applied and the size of the load. For example, if a car is crossing the bridge, you can increase or decrease the area depending on the size of the car. We will start this test again to see if there is any difference to our simulation after editing the load. As you can see, the safety factor is still 15. You can experiment with different loads and constraints when testing your design. This will allow you to find the most efficient, cost-effective, and sturdy design. Now we will look at different types of stress analysis. To start off, we will look at the stress. The green indicates that there is not a lot of stress on the bridge. It also indicates where the stress is mainly located. Now moving on to safety factor. Purple indicates that this bridge is very sturdy. If the color was yellow or red, this would mean that your design does not reach the minimum safety factor and may break when the load is applied. Now for reaction force. This is the part that has the most stress when the load is applied. Now for the strain, just like the stress test, the green color indicates that there is a mild amount of strain on the bridge. Thank you for watching this video. I hope you enjoyed it. See you next time.